In every car we drive today, there's this whole network of, well, silent guardians, really, working to keep us safe. And today, we're going to pull back the curtain on one of the most important ones. It's a tiny little device that's basically the unsung hero of your entire braking system.
So, have you ever had to just slam on the brakes? And you feel that weird, kind of rapid pulsing under your foot? Well, that feeling, it's not a problem with your car. Actually, it's proof that a really sophisticated safety system just saved you from a pretty dangerous skid. But how in the world does it know when to kick in? Well, that's exactly what we're going to get into. All right, so before we dive into the sensor itself, we first have to get our heads around the problem it was built to solve. And that's all about what happens when a wheel locks up. See, when a wheel stops rotating completely during hard braking, it just starts to slide. And a sliding wheel? Well, you've got almost zero steering control. It's a recipe for disaster. And that is where the anti-lock braking system, ABS, comes into play. Now, here's something a lot of people get wrong. Its main job isn't always to stop you faster. The real goal is to keep your wheels rotating just enough so you can actually steer around whatever you're trying to avoid in an emergency. It's literally the difference between a controlled stop and a completely out-of-control skid. So the big question is, how does the ABS even know a wheel is about to lock up? It's not magic. It relies on constant real-time information from its star player, the wheel speed sensor. Seriously, this small but mighty component is like the eye of the entire system, watching every single move each wheel makes. When you break it down, the hardware is actually pretty straightforward. You've got the sensor unit itself, then there's this special ring. It can be toothed or magnetic. That's attached to something that spins, like the wheel hub. And finally, you have a connector that zips all that data back to the car's brain, what we call the electronic control unit, or ECU. These three parts work in concert to create a non-stop stream of data. Okay, but here's the thing. Not all of these sensors are created equal, not by a long shot. The technology has evolved, dramatically, moving from these pretty simple analog systems to these super precise digital ones we have in our cars today. So let's break down that difference.
So on one side, you've got the older passive sensors. Now, these things were pretty clever for their time. They actually generate their own tiny bit of AC voltage, and that's what creates that sort of wavy analog sine wave signal you see. But then you look at the other side, at the modern active sensors. Yeah, they need power from the car to work, but in return, they give you this super clean, crisp, digital square wave signal. And that signal is just worlds more accurate and reliable.
And those old passive sensors, they have some pretty serious drawbacks. They were bigger, they were less precise, and, this is a huge one, they had no idea which way the wheel was spinning. Forward? Backward? They couldn't tell. Plus, they didn't even wake up and start working until you were going about 5 miles an hour. So for any kind of modern low-speed system, they were basically useless. Active sensors, though, wow, they were a massive leap forward. We're talking smaller, way more reliable, and incredibly accurate. They can even tell which direction the wheel is spinning. And you have to understand, this wasn't just a simple upgrade, it was a complete game changer. This new level of precision is the only reason we have modern safety features like traction control and electronic stability control. Those systems have to know exactly what each wheel is doing every single millisecond. So just how precise are we talking? Get this, an active sensor can accurately detect wheel speed down to 0.06 miles per hour. That is ridiculously slow. And that incredible sensitivity is exactly what allows a traction control system to, say, stop your wheels from spinning the very instant you touch the gas on an icy road. It's just amazing. Okay, so we've got this fire hose of super precise data streaming from the sensors. Now what? Well, what happens next is basically a high-speed digital conversation. It's happening between the sensors and the ABS control module. And based on that chat, the module is making split-second decisions about your brakes. This all happens in a super fast 3-step cycle. It goes like this. 1. The system applies brake pressure for maximum stopping power. 2. As the sensor reports the wheel is slowing down too fast, it holds to pressure steady. And 3. If the sensor basically screams that a lockup is about to happen, the system instantly backs off the pressure just a little, just enough to let the wheel spin up and regain traction. And this whole dance, it can happen up to 15 times every single second. That's the pulsing you feel in the brake pedal. But here's where the story gets even bigger, because it doesn't just end with braking. The data from that one little sensor has become the bedrock, the foundation for pretty much all modern active safety systems. This is a really important point. It's not just an ABS sensor anymore. Think of it more like a nerve ending for the car's entire stability system. That same sensor is the main source of information for your traction control system. That's what stops your wheels from spinning when you accelerate. And it's also feeding your electronic stability control, the system that can break individual wheels to stop you from spinning out in a sharp corner. So yeah, you've got one sensor, but it's powering at least 3 critical safety nets. I think this quote from our source material just sums it all up perfectly. It calls it a real-time control system that balances physics, electronics, and hydraulics to keep a vehicle stable and controllable. It's this beautiful blend of physics, super fast electronics, and powerful hydraulics, all working together in the blink of an eye to keep you in control when things get hairy. So the next time you feel that little pulse in your brake pedal, you'll know exactly what it is. It's the sound of this incredibly sophisticated guardian hard at work. And it really makes you wonder, doesn't it? What other invisible tech is quietly doing its job right now to keep your car and you safely on the road?